Hello everyone, my name is Juan Martinez and today I'm going to be talking about linear differential equations. This is a presentation that I'm doing in my Calculus 1 class in Miami-Dade College with Professor Bernardino Gonzalez. This presentation will cover the following. What is a linear differential equation? How are they typically solved? And an application, which is a sample problem involving linear differential equations. Alright, what is our first questions? What are linear differential equations? So as you can see, they are a type of equation that relates a function y, its derivative, y prime, and other functions whose independent variable is also x. Such function has the following standard form, which is dy dx, meaning the derivative of y, plus some function q of x that's multiplying y, and it's going to be, in this standard form, it's going to be equal to f of x, another function whose independent variable is x. Before I start talking about how to solve this type of equation, I would like to clarify the following, which are that the derivative of a function f of x and a function g of x is going to be equal to f of x times the derivative of our function g of x plus the derivative of f of x times our function g of x. Let's recall that this equality right here goes both ways. So if we have something in this form, we can write it in that form, and vice versa. If we have the derivative of two functions being multiplied, we can write it in this form. Keep that in mind. And the second thing that I want to stress or recall is the integration factor. The integration factor is the following. When we have our function, our linear differential equation, in the standard form, our integration factor, mu of x, is going to be equal to e to the power of the integral of the function that is multiplying y times dx. So the integral of q of x in this case, but it could be any function. It's the integral of any function that is multiplying y once we have it in standard form. Alright, how they are commonly solved. So the first step is to put the equation in the standard form, which is the one that we have here. So dy dx, the derivative of our function y, a function whose independent variable is x times our function y, it's going to be equal to some other function f of x. Then what we need to do is to get the integration factor and multiply the integration factor in the entire equation. So we're multiplying the integration factor to dy dx, q of x times y, and f of x. And we change, since we know that the integration factor is going to be equal to the e to the power of the integral of q of x times dx, we put it in the equation. What will happen is the following. We have it right here. What would happen is the following. In this expression right here, when we have the integration factor times dy dx plus the integration factor times q of x times y, when we have that in a normal equation, what we ended up is with the form that I talked to you earlier, that is right here. Yes, we're gonna be having a function times a derivative of another function plus the derivative of the first function times the second, meaning that we can write this function or this equation in this manner. We can write it as the derivative of the function y times the integration factor e to the power of the integral of q of x times dx. And this is going to be really handy because once we get we can now integrate both sides, and as we know, the integral of a derivative is going to cancel out, and we're going to end it up with y times e to the power of q of x times dx, which is going to be equal to another the integral of this size of this part of the equation. So now that we are having a deeper understanding or a better understanding of this topic, let's jump right into a problem, a sample problem. All right, so we have the following problem. Let's read it together. So a tank contains 60 gallons of water with 4 pounds of salt at time 0. So at time 0, when we start, basically, we have a tank of water. And this tank of water is going to be having a volume of 60 gallons of water. And if we were to dry it entirely, this tank, we will end up with 4 pounds of salt. All right? And when time is equal to 0. Let's keep that in mind. All right, let's keep reading. So a saline solution with a concentration of 3 pounds of salt per gallon is being poured into the tank at 3 gallons per minute. So we know that this tank is receiving 3 gallons of water with a concentration of 3 pounds per gallon. It's entering the tank. All right, let's keep reading. Let me highlight this. So it's being poured into the tank and a rate of 4 gallons per minute. All right. At the same time, the tank is being drained at a rate of 4 gallons per minute. Assuming the solution is being stirred constantly, what is the amount of salt in the tank after 6 minutes? Round your answer to 1 decimal place. So what we're having here is that our tank is also being drained by 4 gallons times the tank's concentration. Since we are having what we know is 4 pounds of salt plus the amount of salt that is entering the tank. So what is draining is all of that. So tank's concentration. All right. So let's start by setting up the differential equation. All right, we're going to be starting with the following. So we know that the amount of salt inside the tank is changing. So let's first define A as the amount of salt in the tank. All right, but now the derivative of A with respect to time is going to be the change in salt with respect to time. So the ADT is going to be the amount of salt that is changing within our tank every single time t, in this case is minutes. All right, but let's go deeper. So we know that what is changing basically is that salt is coming in, so we can categorize as rate 1. The rate 1 is the one that we are defining as the salt that is coming into the tank, and we're going to subtract what is going out of the tank. So this rate right here is going to be rate 1. So we have 3 gallons of water that is entering the tank and a concentration of 3 pounds per gallon of water, of salt, I mean. So we're gonna define it later here. But the other thing that we need to keep in mind is R2, which is going to be the rate as water is draining the tank. So in this case, 4 gallons per the tank's concentration. So let's go back in there. So we have that the ADT, it's going to be equal to R1 minus R2. But as we said before, R1, it's going to be what is entering the tank. But what is entering the tank is the water flow, like the water in that is entering, times the salt concentration in, so the 3 pounds per gallon, that's the concentration, minus the water that is going out, times the salt of the concentration, mean the salt concentration, the salt, the salt concentration out. But we know most of these values. We know what is the water in, was, as we know, is 3 gallons per minute. It's right here. So we know that the water in is 3 gallons per minute. We also know that the salt, or the concentration of that specific liquid that is entering our tank, is going to be 3 pounds per gallon. So we note here that it's going to be 3 pounds per 1 gallon. All right, now we have our R2, that's done. Now let's construct our R1, let's now construct R2. So we have the water out, that we know that the water out is going to be 4 gallons per minute, so 4 gallons per minute, and our salt concentration out is going to be a little bit different to calculate, since we said since the beginning that it's not going to be 4 at the first minute, because it's going to be 4 pounds plus 3 pounds are, 9 pounds are coming in, since we can multiply this right here, and it's going to be changing over time. But what we know is that we already define what A is. It's the amount of salt in the tank. So we can, as we did before, that concentration, we can write it as A divided, as we said here, the amount of salt, 3 pounds, so the amount of salt in the tank is going to be A, divided by the entire volume of the tank. But we know that the tank at time 0 is 60 gallons, but at time 1 it's not 60 anymore, because it's entering 3 gallons right here in R1, entering 3 gallons, but 4 gallons are going out. So at the end of the day, we're losing 1 gallon of water, or we are draining the tank by 1 gallon of water each single minute. So we're gonna get 60, which is our initial volume, minus T, because every single minute we're gonna be losing, or we're gonna be draining the tank by 1 gallon. So, as we now have our formula over the ADT, the change of salt during it with respect to time, now we can start solving. So we can cancel gallons with gallons. We're gonna be having 3 times 3 is 9 pounds per minute. So 9 pounds per minute of salt are coming in, minus the gallons that we're getting divided by the gallons. So it's going to be, so this is the volume that at the end of the day this is going to be gallons. So we're going to be cancel it up. So it's going to be 4A, so 4 times our amount of salt in the tank in any given time, divided by 60 minus t. So this is going to be our differential equation. But as you can see, this right here, so now we can write it without the units, so it's going to be easier to do the calculations. 60 minus t. So as you start to see, this function right here could be, as we know in standard form, it could be f, in this case, of t. And if we look closely here, this function, not the entire thing, I'm sorry. Let me put in another color. This function right here, so 4 divided by 60 minus t, it could be our function at q of t. Meaning that if we arrange this function, dA dt plus 4 over 60 minus t times a is going to be equal to 9, we indeed have our differential function in standard form. So as explained earlier, in order to solve this, what we need to do is to get the integration factor of this function and multiply it by all the equation. So let's do it. So as we discussed before, our integration factor mu of t in this case is going to be equal to e to the power of the integral, in this case of q of t, times dt. So in this case, we're going to be having the integration factor mu of dt. It's going to be equal to e to the integral of 4 divided by 60 minus t times dt. So if we have a function in the denominator, the integral of that is going to be a natural log. It's going to be, but since we have a negative in the inside, it's going to be the negative natural log of 60 minus t. So it's going to be our constant 4 right here times negative log of 60 minus t. And it makes sense because if we go here and we derive this, we should get this equation right here. So if we do it really quick, minus 4 negative log of 60 minus t, if we take the derivative, this is going to be this is a constant, negative 4, so I'm gonna put it here. The derivative of the logarithm of 60 minus t is going to be it's going to be in the denominator of a fraction, so negative 4 divided by 60 minus t. But to change rule, we need to multiply all this expression by negative 1. So indeed, we're going to end it up with 4 divided by 60 minus t, which is what we started with. So let's keep going. All right, so as we were working here, we have our function that is going to be e, so mu of t, So let's start again. So mu of t is going to be equal to e to the integral, in this case, of -4 natural logarithm of 60 minus t. Oof, no, the integral. So let's keep working on the integration factor. So the integration factor is going to be e to the power of -4 natural logarithm of 60 minus t. And since we have e to the power of a natural logarithm, which is a logarithm with base e, what we want is to put this coefficient right here in as an exponent due to the properties of logarithms, and cancel out this logarithm with the base. So it's going to end up being e to the power of the natural logarithm of 60 minus t to the -4. So this cancel out. Don't forget the equal signs. And we're going to end it up with 60 minus t to the -4, or 1 over 60 minus t to the 4th power. All right, so we have our differential equation, dA dt, the change of the amount of salt with respect to time, plus 4 divided by 60 minus t times a, which is equal to 9. So now the next step is going to be multiply everything in this equation by the integration factor. So it's going to be mu of t times dA dt plus mu of t times 4 divided by 60 minus t times a, which is equal to 9 times mu of t. But this, it's going to be equal to 1 over 60 minus t. I forgot to put the 4th power. I'm sorry. 4th to the 1 over 60 minus t to the 4th power times dA dt plus 1 over 60 minus t to the 4th power times 4 divided by 60 minus t times a, which is equal to 9 times 1 over 60 minus t to the 4th power. So now, finishing up arranging the equation, we're going to be ended up with 1 over 60 minus t to the 4th power dA dt plus 4, since we have the same base here on multiplying, we can write it as 60 minus t, but to the 5th power times a, which is equal to 9 over 60 minus t to the 4th power. So now we have our function being multiplied by integration factor. But let's take a look at as the following. So if we make a parenthesis right now and we define f of x as 1/60, to the fourth power, and we define g of x equal to 8, is we see right here the derivative, the derivatives Alright, so we have our function already here that is being multiplied by the integration factor. But let's make a parenthesis and think this through. So if we define f of t as 1/60 minus t to the fourth power and g of t as a, what do we have here? Don't we have the derivative of the product? F of t is f of t. Of the product of two functions? Well, here, if we define f of t as 1/60 to the fourth, we have it here, and then, so as to have it clear, so we'll have f of t times the derivative of g of t plus the derivative of f of t times g of t. So g of t is right here, g of t. The derivative of, f of t, the derivative of g of t, which is a, it's going to be dA dt, so it's right here. Now the derivative of f of t, it's going to be 60 minus t to the fifth, and we're going to be multiplying by 4. So yes, indeed, it's right here. And gt, it's going to be a, so it's right here. So this portion of our equation, we can rewrite it as the derivative with respect to t of 1/, so the integration factor, minus t to the fourth power times a. And this is going to be really useful, which is equal to 60 minus t to the fourth power. It's going to be really useful because, remember, what we're looking for is what this formula or this equation is equal to. We're looking for an equation. In this differential equation, the answer is an equation that will give us the answer to this question right here. What the amount of salt is going to be after 6 minutes. So what we can do now, since we have the derivative of all of this, and what we want to do is solve for a, we can integrate both sides. And when we do this, we're gonna be canceling out this, and we're gonna be left with 1/60 minus t to the fourth power times a, and the derivative of this portion. So let's do it. All right, so the integral of a derivative, since they are inverse operations, it's going to be 1. So 1 times all of this. So 1 divided by 60 minus t to the 4th power times a. And now in this part, the integral of all of this, it's a little bit ugly, but we can rewrite this as 9 times 60 minus t to the negative 4th power. So let's stop for a second and ask ourselves, what function, if I derive it, it's going to get this function? So what function f of x, when I derive it, it's going to be equal to this function. So if we know that due to the power rule, once we derive an equation, what we are basically doing is subtracting the exponent, it makes sense that our original function should be 60 minus t, but to the negative 3, because when we go to the derivative, it's going to be minus 1, so 60 minus t to the negative 4. So for that part, we are good. This is a constant, 9 is a constant, so it stays the same. So what we need to do now, it's divide by negative 3. But we also need to multiply by negative 3. Why? Let's go it. So if we take the derivative of this function, it's going to be, so first of all, we need to, oh, I forgot the 9 here. We need to pass this 3 as basically as a multiplication number that is that's multiplying the function. So 9 times negative 3 So the next steps to take right now is going to be to take the integral in both sides. So the integral of a derivative is going to be the same function. So 1 over 60 minus t to the 4th power times a. And this portion right here, it's not as easy to see, but we can rewrite this function as 9 times 60 minus t to the negative 4th. So when you want to integrate something, what you basically are looking for, you need to think of this equation as the derivative of some function f of t. So the derivative of some function f of t is going to be 9 times 60 minus t to the negative 4th power. So when we derive something that is that has an exponent, that exponent is subtracted by 1, and also it starts to multiply our function. So our function in this case doesn't change, it's 60 minus t. So a number that when we subtract by 1 gives you -4, it's going to be -3. Since 9 is a constant, it stays the same right here. And what we are looking for now, it's a number that when multiplied by 3 and then by -1, because remember the chain rule, it's going to be 9. So the number is 3, and we can check it right now. So if we go and we multiply 9 times -3 divided by 3, it's going to be -9. But when we do the chain rule, when we calculate the derivative in the inside, we indeed are going to get this function right here. So the integral, I forgot to put dt, I'm sorry. The integral of this function right here, it's going to be 9 over 3, or 3. It's better written like 3. Let's put the 3 in there. I just wanted to write it that way to have it clear. So 3 times 60 minus t to the -3 plus some constant c is going to be equal to 8 divided by 60 minus t to the 4th power. All right, so now we can write a as 3 times 60 minus t to the -3 power times 60 minus t to the 4th power plus c times 60 minus t to the 4th power. So a is going to be equal to, since we have the same variable, if we're gonna want to see it that way, and we know that the exponent, this is -3 and this 4, we're gonna end up with 3 times 60 minus t to the 1th power, so to the 1, which stays the same, plus c times 60 minus t to the 4. We haven't finished yet because we do not know what c is, but we can figure it out from our initial value. So we know that, this part now. We know that when time is equal to 0, so when t is this t and this t is equal to 0, we know that A of the amount, or the amount of salt in the tank, is going to be 4 pounds. So as I was saying before, when c, it's, we want to look for c in this equation right now in order to finish up knowing what the entire equation is. But we know is that when t, with the time, is equal to 0, we know that the amount of salt, or meaning A, is equal to 4. So 4, it's going to be equal to 3 times 60 plus c times 60 to the 4th power. So 4 minus 3 times 60 is 180, minus 180 is going to be equal to c times 60 to the 4th power. So negative 176 is equal to c times 60 to the 4th power, or negative 176 divided by 60 to the 4th power is equal to c. So now we have what is the c value. Therefore, when we plug it in this equation, we will know what our answer is. So let's go. So as we discussed previously, our C value is going to be negative 76 divided by 60 over 4. So our function, the answer of our differential equation is going to be the amount of salt going to be equal to 3 times 60 minus t plus, minus 176 divided by 60 to the fourth power times 60 minus t to the fourth power. So let's try to see if when we plug 0 in this equation, we will get 4 pounds. So when we have t equal to 0, it's going to be it's going to be equal to 3 times 60. So 180 minus 60 to the fourth times 60 to the fourth. So since this is divided and this is multiplied, and we can cancel that out, so we're going to be having 176. So yes, when t is equal to 0, it's going to be 180 minus 176 or equal to 4. So the first conditions are met. So let's now get what the amount of salt after 6 minutes is, which is our question. So now let's find out the answer to our question. So the amount of salt of t minutes is going to be 3 times 60 minus t is equal to 6 minus 176 divided by 60 to the fourth power times 60 minus 6 to the fourth power. So A is going to be equal to 3 times 56 minus 176 divided by 60 to the fourth times 50. So the amount of salt is going to be 3 times 54 minus 176 divided by 60 to the fourth times 54 to the fourth power. So let's use a calculator to make this, to solve this equation. So 3 times 54 minus, let's put parentheses in here, 176 divided by 60 to the fourth power times 54 to the fourth. So our answer would be 46.52. So 8 is going to be equal to 46.52. And if we read closely, we need to round the answer to one decimal place. So our final answer is going to be A is equal to 46.5. Here it's not 0.4, it's 2. So here we go. This is our final answer. And I hope you like it. And don't forget to leave a like and subscribe. Good things are coming up. My name is Juan Martinez, and see you in the next one.